and wins and the new designs. That includes developing the patent portfolio for Doosan. So
Right.
by
And
submitting.
why? And why did you need to work, as in work on these new technology initiatives? Was this like a company initiative to move ahead in the competition, or as in, what? How would it add value to the company operations?
Okay, so basically they are relatively new in the business. So
Okay.
Siemens and GE are in the business for quite a while.
Yeah, they are the
Yes,
kings, giants,
yes,
basically.
yes. So Doosan is relatively new. So they are expecting, they have some contract from the Korean government to work on building these new technologies. Okay,
Hmm.
as such, they want to make products that made in Korea, designed and manufactured in Korea that they want to use so that they could minimize the flow of technology from outside countries like
Mm-hmm.
Germany or US or Japan, and they can able to build the technologies on their own that can be implemented in Korea full scale. So that's the plan.
Right. So
So
you oversaw two or three different things. One was managing and improving in-house products, right? In-house systems. The
yes,
other, working on new technologies with
hmm
you know uh, new technologies that were to be developed outside the company location, right? I mean, that were to be developed internationally in Korea.
yes, yes.
All right. All right. And what kind of teams did you work with? What different stakeholders did you work with?
The stakeholders would include like marketing, like they provide the inputs for making the product requirements,
All right.
and then work with the systems level product requirements team and the project management team, and then work
Hmm.
with the manufacturing, supply chain, and the engineering team to make the product. And
Right.
occasionally work with universities or third-party vendors to make uh, the technology development parts for testing to validate the
All
technology.
right. Right. All right. So you were involved in the product development process from the start to the end. So gathering customer requirements with the marketing department, right?
Yes,
Analyzing those and turning those into feasible designs, and then
yes,
overseeing the production process till the
mhm,
testing,
yes.
right?
And it's a
All right.
holistic approach. So I would
Hmm.
say from start to end, I'm pretty much involved in almost all the aspects of component design.
Hmm. Right. All right. And how big were these projects again? How big were these individual products, kind of like budget wise that you worked on?
Budget wise, like on an average, we spent close to 2 millions to 2 to 5 millions on each and every product. So, for
Um,
example, I mean there are different there are different modules in that. Okay, for
hmm.
compressor itself, we spend like 2 to 5 millions. But if you look at the overall gas turbine, we may be spending close to $15 to $20 million per year.
Right. So could I generally say that you kind of like worked on multi-million dollar
Yes,
projects?
yes,
Because that would kind of generalize that, right? And you can explain that further in an interview.
yep, yep, yep.
Right. And just one thing, Krishna. So these, how many new products did you work on? How many product maintenance or product, product improvement projects did you work on? Just, an overall
At Doosan
number
or
of, yeah,
at
Dusan,
Doosan
at
or the
Dusan.
overall?
No, Dusan. So we will be going position by position
Okay,
so that,
at Doosan,
there's no mix and merge of information.
I'm working on like two products, on the development of the two products
Hmm.
and two technology
Two new
developments,
products.
two new products and two technology developments,
Hmm.
and product enhancements and service products is probably two.
Two. All right.
Yeah.
So let's just talk about the two new products that you worked on. So what
Hmm.
again? What kind of products were these? And specifically regarding these product development, what kind of challenges did you have to face here at Doosan?
Okay. So for these products, the challenges would include like building the design and work instructions and the design
Mm-hmm.
methods, and
Mm-hmm.
also addressing the manufacturing challenges, cost aspects of the product, right from the conceptual phase to the detailed design phase.
Mm-hmm.
So that would be a challenge since Tucson has never worked on the gas turbine technology development.
Mm-hmm.
So kind of I need to leverage on my past experience and then work on developing the design concepts and then offer the technical manager role in validating the designs and then accepting the designs and finally releasing the designs for production, like manufacturing.
Mm-hmm.
Okay?
Mm-hmm.
Once it goes to the manufacturing and then we get some feedback from the suppliers or even internal manufacturing. So what's the issues and how we can address that. So those sort of the things.
Mm-hmm. All right. So, what kind of design issues did you, as in, what specific design issues did you have to face when working on these products?
The specific design issues include like meeting the fatigue life, and there will be element of risk of fretting, which are like purely mechanical related issues.
Hmm.
These are we call the durability issues. Like
All
some,
right.
it can run for like 1 2 years.
Hmm.
After that, we may have to replace the part.
Hmm.
Then we call that as like less durability. So
Hmm.
typically we expect the parts to last longer, like 3 to 5 years or 10 years. That's called the
Hmm.
durability. Okay, so if the
Hmm.
parts are durable, then it offers added value to the gas turbine and to the customers. And if
Hmm.
the parts are reliable in the sense the probability of failure is low, then
Hmm.
it will be a low risk to the warranty cost.
Right. So, how did you overcome these challenges, Krishna? How did you ensure that these
Uh, for
durability aspects are met?
hmm.
How did you turn around the picture?
So, for example, we have some internal tools to validate the design capabilities and durabilities, and
All right.
some of them we don't have the tools where we have to leverage on experience and
Mm-hmm.
engineering judgment. In that case, what we typically do is we put some element of risk and perform a risk assessment, and then release the parts which are risk release,
Mm-hmm.
and then over a period of time we validate the risk and then do the necessary changes in the design. Once the part goes
Mm-hmm.
to production and operating in the field, then implement the redesign and replace the parts in the field whenever there is an opportunity. That
Mm.
would be the scope of product improvement or enhancements which we typically do right after the product has been released into the
Right.
market.
Mm-hmm. Mm-hmm. All right.
So
And yeah.
So not all products like will meet the durability. Sometimes some products will fall short of the durability.
Mm-hmm.
For those parts, we need to do the risk release and then uh, release a risk assessment and do our inspections
Mm-hmm.
quite frequently. Like we set the inspection limits as well, and then
Mm-hmm.
based on the inspection limits, once it's in the field, we keep inspecting the parts, and if we see any cracks on the parts or any
Mm-hmm.
issues, we kind of like closed loop system. We get the feedback from the service or the field team, and that
Mm-hmm.
we use to revise our analytical models and then perform the redesign solutions or do uh, mitigation solutions for
Mm-hmm.
short time, and redesign would be the long term solution.
All right, all right. And on the manufacturing side, what you mentioned some challenges that you face for these new products that you developed. How did you address those challenges?
So for manufacturing challenges, we typically observe is the quality notifications. Like some of the parts did not meet the quality notifications. So
Mm-hmm.
I need based on certain set of standards, I have to disposition whether it's accept the part or rework, which involves repair, or
Mm-hmm.
sometimes it could be even scrapping the parts and they have to make the new part. Then the other aspect would be if the quality notifications are recurring, then we have to issue a CAPA, which is called corrective action and preventive action,
Right, yeah.
where we need to do the root cause of the issues and then we need to find out what could be the corrective action and preventive action and then put that in a lean system. I'm not that experienced with that, but I've worked with some of the team members to go through that lean system where elimination of waste. So the best way they could
Mm-hmm.
elimination of waste is to go through the process of DMAC, like define, measure, analyze, and interpret.
Right.
So we define what is the issues, then we measure the process changes, we analyze it, and then we interpret what could be the causes of changes, and then we do the necessary changes, and then we reperform the uh, manufacturing system overall process and how it's
Mm-hmm.
affecting the quality of the product.
Mm-hmm.
And
All
then
right.
once we do this changes and we found out that the new process is improved and we
Mm-hmm.
eliminate the uncertainties in that. For example, like in one of the cases where we have a issue of parts that are not meeting the tolerance specs, and we went ahead and we looked at the issue why the parts are not meeting the tolerance specs. So we went to the supplier. We did the investigation, like doing some measurements on a first article inspection.
Mm-hmm.
Okay. So, like, I forgot to mention about the first article inspection as well. So, I think I'll take a step back. I'll explain you. Like, once the parts are manufactured, then these
Mm-hmm.
parts has to be reviewed by engineering team members or the engineering manager for the quality of the parts. So, these are
Right.
called the first article inspection, okay, or factory
Mm-hmm.
acceptance testing. What we typically do is we go to the supplier, we look at their process, and we look at the part, and then we do the quality check of all the parts, like what is the specification we provided and what is the supplier or the manufacturing process they achieved, and we compare back and forth, and then we
Mm-hmm.
kind of like assign a quality notification, the quality supplier quality document or engineering acceptance quality document, where we sign on the engineering acceptance quality document that these parts met our quality standards, internal quality standards. Okay.
Mm-hmm. All right.
So similarly, when we see some deviations, what would happen is the parts, they call a PPQs in Siemens, not here, but PPQ is like
Mm-hmm.
part process quality.
All
Like,
right.
so they measure the part, process, and quality aspects of that, like quality of the part and the process methods that deviates the quality. So we go through
Mm-hmm.
the PPQ and we find out what are the changes we need to make to meet the quality standards for the part. So the process changes would affect the quality of the part. So thereby we change the process and then we remeasure again the new set of standards with the changing
Mm-hmm.
process, and then
Mm-hmm.
we reevaluate whether the new process is exactly producing the same parts with less scrap or not.
Hmm. Right. All right. Makes sense. And any other particular challenges that you faced when working on these specific new products in terms of like the budget management when working with external vendors
Mm,
or in terms of the testing aspect? So we talked
mm,
about the design and the manufacturing aspect, but in terms of
mm.
testing or anything of that sort.
I mean, the testing, it's a quite common issue sometimes. We do face it. Like, for example, some of the parts used by the third party vendors are like existing parts, and what would
Hmm.
happen is sometimes they kind of like having some technical issues like the parts are broken when we are doing the
Mm.
testing. So we have to stop the test and then install those failed parts and then redo the testing. There might be some
Mm.
delay or a lag in the process. So in that case, there's nothing we could do rather than wait for the new parts to arrive. Okay. So,
Mm.
but what we typically do at that time is make use of the existing time, like whatever the
Mm.
test we have done till now. We try to gather the data and do a correlation with the analytical models to get the overall feel of the existing rig and how it's behaving, whether it's behaving on par or not. If it is
Mm.
behaving on par, that's fine. If it is not behaving, then we have to go and redo some root cause assessment. For recently, there are like a high deflections we observed on some of the stages. So I went ahead and looked at what could be the issue with the help of the team, and we found out like
Mm.
the deflections are higher at deflection in the sense the parts are moving more than what we actually anticipated.
Anticipated, yeah.
Yes.
Mm-hmm.